One type of requirements is called domain requirements, i.e. they're coming from the technical domain. For example, if you're looking at maybe a train control system or railway control system, you need to get some information about how trains are being controlled. Maybe some formulas, some rules, some procedures that you have to follow. Yeah. So here the system's operational domain imposes requirements on the system. Yeah. So train control system has to take account the braking characteristics in different under different weather conditions. Particularly if it's gonna to control the train operation, and maybe things about the signaling procedures. A large part of that, a large part of the railway traffic safety is to do with control systems that can automatically stop trains if they're operating under maybe dangerous conditions that could lead to an accident. For example, in winter, if the tracks are covered with leaves, this can actually cause the train to slip and take much longer a distance to stop. So you need maybe to put on alerts earlier on, maybe stop trains that are going too fast, etc., etc. So this sort of technical domain and technical knowledge has to come from people who actually control the domain. So maybe they say if it's raining or if it's a certain part of the autumn season, then the braking distance will have to increase, and therefore maybe you put a red signal much earlier on than you usually do. Yeah. So this is to do with the actual technical domain. Maybe even with medicine, like you prepare an infusion in a certain way. You enter details about the patient, their weight, their age, and on that basis you have to calculate a dose and a rate of injection, etc. So again, this comes from the technical domain of intravenous infusions. Yeah. So you need to get a little, or quite a bit maybe sometimes, into the technical domain that you're dealing with. If you're dealing with a shop or an inventory control, again, you need to know something about inventory control and the various formulae that control that. Yeah, because domain requirements can actually be in the form of new functional requirements or constraints on the existing requirements, or whatever you've been given so far. Yeah, so there should actually be extra layers of requirements, either functional or non-functional or constraints. Yeah. To define specific computations is where you have like a particular formulas. For example, here there's a formula about how you calculate the deceleration of a train according to a particular variable, as well as the gradient along which the train is traveling. So again, this is something that comes from the technical domain of rail control. And the air traffic control, for example, you need to know that there's a safe vertical separation distance and there's a horizontal safe separation distance. If exceeded, i.e. if it's narrower or smaller than the established safe domain or safe distance, then an alert needs to sound, for example, in the air control room. All these are technical domain requirements. You need to be able to interview and speak to the experts in the domain, the specialists in the domain, to understand what is really happening. So you need to spend some time studying and understanding the domain really, or maybe get a specialist to explain it to you. Yeah, because it can be difficult to understand how these inputs from the domain can actually affect your existing requirements and so on and so forth. Let me show you this this diagram. Actually, you need to look beyond the immediate technical domain as well. So, for example, this is about the intravenous infusions. Yeah. So this is like the bit in yellow here is the core domain of intravenous infusion in the wards. Yeah, where staff, nurses, and doctors and medical practitioners interact directly with the intravenous infusion process, the devices, and the patient. And then you have a wider system here, the hospital. Yeah, this is the hospital, and this is something called the trust. This sort of pinky thing is the trust, which is an organizational level above a hospital. And then there's the entire healthcare system, and there's the government, and the wider environment has the industry and manufacturers. All those bits, all those circular domains could have stakeholders or constraints that are imposed on your system And sometimes you need to get into these and find them out. I'm not saying you have to investigate all these levels, but you need to be aware that sometimes you get requirements from levels that are not immediately or directly connected to the actual system domain that you're working with, like the technical domain you're working with. Although we have some technical domain requirements, some can actually come from outside. For example, when you have a hospital policy on record retention, or medications should be stored and handled, etc., etc. So it's just about being aware of the contextual levels that you can have surrounding your particular system, and remembering the need to understand some of these in some depth. Are there any questions so far? Okay, so remember, you don't just concentrate on the very core technical thing and you run away and start writing programs and writing code to satisfy only this bit. You need to be aware of what's happening around them. Now, how do you get into these? Well, we've got some sort of requirements investigation or requirements analysis techniques. So I'm just gonna go into that. Requirements elicitation techniques. Sorry, there's a typo there. Now, we mentioned interviewing as one of them, remember? It's really essential that you're a good interviewer. I suspect most of you have done that before. But normally we need to interview a number of stakeholders. So users, managers, maybe clients, sponsors. And there are many types of interviews. I mean, you can actually like whole books of interviews and how to prepare for them. They could be formal or informal. They could have structured or semi-structured or free form or unstructured interviews with a variety of stakeholders who are involved in the requirements engineering process. Yeah. Again, in the actual text of the interview or the actual preparation of the interview, you can have closed interviews based on predetermined lists of questions. Also, you can call these highly structured or structured interviews with closed questions, and you can have open interviews where you leave some freedom for the interviewee to wander about and get into topics that maybe you did not plan to explore at the beginning or during your preparation. So that's okay. Now, there's a few guidelines for interviewing. I don't want to go through these. I'm sure you've seen these before, but you have to be aware of good interviewing guidelines, how to prepare for them, how to start them, how to introduce yourself, how to close them. And sometimes you have to, depending on the research protocol you're following or the company protocol you're following, but you need maybe to get consent from the people you interview, and you need to assure them about maybe confidentiality and stuff like that. Yeah, this is also important. How about the confidentiality of the content of the interview? If someone tells you something in the interview, would it be possible for outside parties to identify the person who said that? Yeah, it's that sort of stuff. General sort of ethics and guidelines or codes of practice around interviewing that you need to be aware of. Yeah. So let's have a little chat on this. How would you prepare for interviewing stakeholders in your project? Okay, I need you to think of answers to these, please, and raise your hand once you have one. What would be the first thing to do when you think of your particular project? Maybe the electronic medical record or the car parking, the AC car parking application. What would the first thing you need to think about when you prepare for interviewing? Or maybe you can think of it as a more general thing like collecting and eliciting requirements. What would you want to do in preparation for elicitation of requirements? Yes, Habiba?
I'm not really sure, but I think I first want to know why they're interested in this project in the first place. What is it that attracts them, and how do they sort of visualize it, and why do they think there's a need for it? Because I feel like these questions will help me sort of get a get a stronger grasp on the perspective I need to take, like how sort of create a better vision for what I want to do.
Fantastic. That's a very good answer. So we say why, yeah?
Yes.
Do you need this system? Yeah? Why do you want this to be done? Yeah? What do you bring me in for? Very good. Okay, anything else? Muhammad?
We could also discuss whether or not there are sort of inefficiencies within their company to sort of figure out what needs to be focused on.
Yeah, good. What are the inefficiencies or problem spots? Yeah. No, I'm just making too many typos here. Okay, good. Anything else? Habiba, you still have something to add?
I'm not sure.
Okay, that's okay because your hand is still up. Okay, Muhammad Ibrahim, please.
Maybe maybe we could ask like how technological, or like try to find out how technologically literate they are and their users as well.
Okay, who are they? By who do you mean?
Like both the users and the stakeholders, because
Okay,
like the stakeholders might not be as technologically literate, so they wouldn't exactly know what they might
very
want,
good.
or what they want might be feasible.
Yeah, exactly. Actually, I'll tell you what we call that in human-computer interaction. We call it making user profile descriptions. Yeah, you prepare user profiles for end user. You find out who they are, what is their education like, what do they like, what do they dislike, what are the sort of pressure points or hate points or things they like or dislike or prefer to do to understand users better. Yeah, maybe also you can do that for stakeholders, but stakeholders normally, you know, not all of them would use the actual system. The people who are going to interact directly with the system, we call them users. So that's why we make user profiles. But stakeholders can also be described, but not maybe in the kind of detail that you need to do for users. Okay, excellent. What else? صح؟ هم مين? Who are the stakeholders? صح? I think that would be the first question to ask.
Yeah.
Who are the stakeholders? Yeah. Who are the users? And maybe start from that, and then once they give you some users, say why. You know, why do the users need to do this? And you get the answer like, oh, because the government has this rule about document retention, or about how the taxes are calculated, or you know, national insurance, or safety measures for the stock you have, etc., etc. Yeah. So just keep investigating. And really, I think for me, the act of doing good requirements engineering is a lot about asking the right type of questions and being a good inquisitive investigator. It's like a private detective, really, or like, you know, like a detective was trying to solve a crime. You just keep asking, why are you telling me this particular thing? Or who does this and why, under what conditions? What is the purpose of doing this? Who's going to benefit? Yeah, what influences the decision, etc., etc. تبقى عامل زي المخبر يعني واخد بالك وكيل نيابة بيحقق because you want to you don't want just to get superficial requirements that maybe are not very meaningful. You need to get a bit of depth as to why these requirements are needed and why are people telling you this, because later on you will discover some conflicts. Yeah, so some requirements just would not square off with each other. They would be conflicting. Yeah, so if you know why they want these things, you know who to ask, you know how to resolve these conflicts, because you go into the basis of them by asking why. Okay, all right. So some advice I'll give to people who are actually doing requirements analysis and innovation is to listen a lot. Be a good listener. It's a very, very important skill. If you're surveying or interviewing or observing, you need to pay a lot of attention to everything that goes on. You need to develop your powers of observation and your ability to listen. You need to observe, watch, measure, ask questions, etc., etc. So these are really, really important. I also recommend this kind of thing for people who are interested in innovating new products. Yeah, getting to know the pain points of your target community. You need to know what is bothering them, and maybe knowing what is bothering them, you can actually come up with a nice system proposal and some requirements that would actually make your system a success to use. Okay. So some stuff about interviewing in practice. You normally use a mix of closed and open-ended questions or open-ended style interviewing. It's important to have some part, at least of the interview, to be open-ended, because sometimes your stakeholder or your user can give you input, or give you information, or identify factors that would not have occurred to you at all. Tamam? Something that just would not have come to your mind. So it's really important to give them a chance to talk freely for a bit. Because remember, we try to be accurate, we try to come up with the relevant and valid requirements. We try to engineer a product that is successful and usable and people really would want to use. Okay? Interviews are good for getting an overall understanding of what stakeholders do and how they might interact with the system. Yeah, it's getting close to users. Getting close to users is really, really important. I should say also stakeholders in general, because some requirements would come not from direct users, but from stakeholders. Okay. Now, sometimes if the specific domain terminology is hard for you, yeah, so what do? What if you interviewing a doctor or nurse or an air traffic control officer, and maybe they say things, oh, horizontal separation, for example, for air traffic, or infusion rate, for example,
We can
titration.
ask them to clarify it more, or like make it, or like we can translate it, just write down the term that we do not understand, and when we go back, we find the correct
Yeah. Exactly. You write these things down. Sometimes actually the interview time, the sort of the duration allocated to the interview is insufficient for the domain expert to explain to you difficult or unusual terms in full. So maybe make a note of them. You should make a note of them, study them, and maybe consult another expert. Yeah, maybe speak to another expert, or go back to the same expert and say, look, can you explain this to me and how this works? That's why in interviews, you always leave a space at the end and make sure that we say, can I come back to you later if I have any questions? It's very, very important. Leave the door open. Yeah, may I, how do I contact you, or can I contact you again later if there's anything that's not clear to me? Yeah, so you need to do a little bit of time actually studying the specific domain. So if you work with lawyers, after a while, you actually get to know some of the terminology that lawyers use. Yeah, they say things like the dockets and discovery and without prejudice and stuff like that. And you ask, what do these terms mean? So you need to make a note of them. Don't just ignore them, please, because uncovering the meaning of some jargon can actually have a big impact on your requirements or the details of your requirements. Okay. Sometimes the domain knowledge is familiar that people find it hard to articulate. Like, I once asked a nurse about what did she mean by titration, and she couldn't quite explain it to me until I had to go and look it up later. It's a term that is used in intravenous infusion in the medical domain. So you need to look at more technical documentation, do a bit of studying, and be able to go back and ask them to understand these terms well. So don't be intimidated by the terminology in the domain. Make an effort to understand them. It's good for you to understand them because it can actually save you from making serious errors in the requirements or serious misunderstanding. Do not assume you understand the meaning, even if it seems obvious to you. As I say to my students in design, بلاش فهلوة. Yeah, ما تتفهلوش. Don't guess the meaning of something and build an understanding on it and discover later that you were wrong or inaccurate or your understanding was incomplete. Yeah, so be modest, ask questions and find out more. Okay. Okay. as a result of collecting the data. Now, I don't want to talk about data gathering. I'm sure you've seen these before. Observation, inspecting documents, interviewing, etc. I'll talk about ethnography a bit more, which is a very important technique. But as a result of looking at what people do and what functions they need, you can develop things called scenarios. Scenarios are a good way of documenting requirements. Because after collecting requirements, you need to document, you need to write them down. Yeah. Anyone confused by the term scenarios? What does that mean? Have you seen them before? Yeah. Just look at this slide for a bit. So there are real-life examples, narrative descriptions of real-life examples of how a system can be used in practice. So if I'm describing to someone how to use an ATM, I would say, okay, a customer or bank client approaches an ATM, they get their the ATM card out, they insert it into the slot, and they enter a PIN number, and then they select an operation, and then maybe the PIN number is incorrect, maybe the card is damaged, maybe the machine, is faulty, yeah, and then you start describing various scenarios or eventuality of how the system should behave in each case, or what response the user should get in each case, yeah. Here are some definitions of scenarios. By the way, I can tell you to treat scenarios and user stories to be equivalent for the time being, yeah? So, you can just say scenarios would be like equivalent to user stories for the time being. Some people make a distinction. I would say don't bother with that right now. We can distinguish between user stories and use cases later on. But let's just look at users as scenarios about examples of use of your site or system or application. Yeah. Actually, I'm gonna take the site off because this is not exactly relevant to you. Here's a description. A scenario is a short story about a specific user with a specific goal at your site or application. Scenarios are questions, tasks, and stories that users bring to your website or application. Yeah, because this is all about usability of websites, but the same can be said about applications that the application must satisfy. Scenarios are critical both in designing websites and applications and for doing usability testing or just system testing in general later on. Here's another example, another definition, a narrative description of what people do and experience as they try to make use of computer systems and applications. Yeah. One very important thing about scenarios or user stories is that they encourage empathy. What do you understand by empathy? Hello? Anyone wants to volunteer a definition or understanding what empathy
Yes,
is?
please.
Definition of what?
Empathy. This one, this highlighted word, empathy. Do you hear me, guys, properly?
Yes. Empathy
Okay.
is like someone who has empathy. I know it in Arabic يعني تتعاطف مع حد.
أيوة. Yes, that's correct. يعني تحط نفسك مكانه.
بالظبط.
Yeah, تحط نفسك مكانه. تخيل نفسك مكانه. اليوزر ده عايز ايه بالظبط؟ هو بيستعمل الابلكيشن ده عشان عايز يعمل ايه؟ What task, what goal are they trying to satisfy? So when you build scenarios, it encourages empathy. It helps you empathize with the user. تمام? So for scenarios, we need to know for the users, actually we should say user groups. Yeah, ما عندناش just one user. We have types of users which we can classify into user groups. تمام? What they want to do, what are their goals. تمام?
Doctor, I have a question.
Please do, ask.
I read once in while doing an interview, there's some sort of interviewing, like a method called ethnography, where you like spend time with the customer and audit or observe what he's doing.
Yes.
Just write down. Is this kind of method هنا معانا في الكورس ولا لا?
Absolutely. If you look ahead at the slides, you find that I've got quite a few slides on ethnography.
Okay.
تمام? I'll come to that. I mean, hopefully before the end of the lecture.
Okay.
تمام? Okay. But thank you very much. That's a good question. It's definitely on the cards with us here in this lecture even. Okay, so we need to understand the users better. We need to know what goals they're trying to satisfy. We need to know why they want to do that. What are the motives? Yeah, what is the ultimate goal of carrying out these tasks? Yeah, actually, I should say here, this is the tasks. What are the tasks that the user needs to perform, and why, as in the ultimate goals of the users. Well, oops, what am I doing here? How did that happen? Okay. Okay. And what are the expectations, maybe? What do they expect? If you're talking about something more innovative, you want to develop a product that is competitive in the market, I would say you need to find out what are the pain points. Yeah? الحاجات اللي بتوجعهم. What things they want to change. What are the things that bother them, that are bothering them. ماشي يا جماعة? So this will be based on stories that you hear during data gathering or data analysis. Other examples of realistic interaction with the system that you are designing. A way of getting into the user's mind and putting yourself in their place. Here's some values of scenarios. They give you how-to perspective about the average user or users, because as I said earlier, we normally have user groups, types of users there is, and each group would have its own profile in terms of computer literacy, technology experience, maybe age and education, language proficiency, etc. You need to understand, they help you understand how multiple tasks occur together in the real world. They also help you verify your elicitation and understanding of tasks. They help you discover relationships among tasks, maybe precedences and dependencies and stuff like that. Yeah, they help you understand user decision making. They help you determine factors and motivations and sort of concerns and issues, pain points, as I said earlier, yeah, that are influencing the use of your system. Sometimes this is really important. For example, if you think about Twitter, Twitter obviously is a very popular application, but at some point they were very concerned, the investors and people who are managing the application, that the user base was not increasing at sufficiently fast pace. So you had a small core of, relatively small core of users who are using it, but they're not increasing. Yeah. So what the question was, how to motivate more users to join in? Exactly like Facebook when it recommends to you people to connect with, like LinkedIn that suggests connections. So yeah, so if you know something about what motivates people to join in, and joining in for you means more income because you have a bigger user base, and that's why an application like WhatsApp was sold for something like $16 billion to Facebook, because lots and lots of people were using it. There's something like 2 billion users of WhatsApp. So the question is, what motivated them to do that? Yeah. And this helps you definitely engineer the system and come up with features that are useful or motivate more users to join in. Okay, it also helps you, scenarios help you provide or communicate how-to statements to the developers about users and functions, maybe algorithms and ways of computing things and ways of performing tasks. Yeah. Okay, so here are some examples for scenarios for collecting medical history in Medcare. You can put something about initial assumptions, like it's like a precondition for this scenario. How does the scenario get started? And here's the normal course of events. Yeah, the normal flow of events. Okay, the nurse searches for a patient by family name. Then if there's more than one patient with the same surname, the given name is used to identify the patient. Yeah, quite often, definitely in the UK, once you give it, actually even before you give a name to make an appointment, they ask about your birth date, because they've found out from practice that very few people share birth date. So birth date is highly discriminating. So if you give them your birth date, the full birth date, they come up with very few set of instances, and then they ask about your name. Yeah, but if you do it the other way around, if you ask about a name, it is much more likely that many people would share the same name. Yeah, especially if it's European or English name, and then the search time will be longer. Yeah, because you have a longer list of people with the same name, and then a second discriminating attribute would be maybe birth date or first name. You know what I mean? It's this sort of thing. So you need to get to know how people actually work on this. And this is like maybe an interesting piece of information when the receptionist in the medical center say, oh, I always ask about the birth date first, not the name. Yeah, so it gives you something about that maybe is different or any in conflict with your assumptions about how the system is being used. Okay, انت فاكر ان كل الناس بيسأل على الاسماء الاول, but actually when you observe how they do it, they say, oh, we actually ask about the birth date first because of the obvious reason or because of the reasons I've just mentioned to you. Yeah, وهكذا. So this is a description. I personally like it to be a little bit more structured, like with the numbers, not bullet points, numbers, so that you can actually describe steps, and then a bit about what can go wrong. So this is the exceptional flow of events. Maybe the patient's record does not exist, or cannot be found, or the name is recorded incorrectly. Yeah, and then you describe what would happen in every case, or what would go wrong, and what the sort of eventualities that can make the system hard to use or lead to errors, etc., etc. Yeah, and maybe other activities that can be carried out. And then this is the not the precondition, this is the post condition. Once the scenario is completed, how the system should be configured, what the state of the system should be like. It's an informal, as I said, just based on plain English, plain natural language narrative, but it's a useful narrative in helping the requirements engineer visualize or imagine how the system is going to be used. And it's very easy to get input from your users or stakeholders because it can be easily reviewed. It's format that is easy to inspect. And this is very, very important when you're thinking about requirements documentation or modeling in any case. You need to come up with a formalism or a notation that your users can easily understand. Because if they can easily understand your notation, not necessarily natural language, but if they can understand it, then they can comment on it. They can discover inconsistencies or errors or misunderstandings. So it's really in your interest to use an easily accessible tool for requirements documentation. Yeah, use cases are a bit different. I mean, they are scenario-based, and in the early days of using these tools, people used use case and scenarios as being very, very close to formalisms. But actually, when we describe use cases, we say more about how the system is going to respond. So we talk about events from the users and events from the system side. Anyway, there are scenario-based requirement discovery technique in UML, which identify the actors in interaction and which describe the interaction itself. Yeah, I think visually, you know that this is the top level or the most widely known diagram for representing use cases. This is the diagram, not the entire model, because the entire model needs you to add narratives, yeah, under each of these use cases. So each of these ovals is representative of a use case. Obviously, you need to observe or make sure that the names of the use cases are expressive, yeah, or self-explanatory, واضحة, ماشي, and that no two use cases are given names that are too close to each other, such that the reader would be confused. مش كده? And of course, you cannot duplicate them. It's like there are data names in a program. You do not duplicate the name for two different use cases. But at another part or in another part of the model, you need to give a narrative for that. And I think we've seen narratives that look like that for documenting use cases. Was it here somewhere? Yeah. Sorry, it's something like that. I cannot find it right now, but it's very similar to a table representation with who's doing this and what the system response is going to be like. Let me see if I can actually find a bit from another presentation with more detail. You'll find some in your textbook. In the meantime, you can just think of questions maybe you'd like to ask me while I bring up this other presentation. حد متلخبط يا جماعة موضوع use cases والscenarios؟ No. Okay.
Yes, doctor.
Yes.
I didn't hear the question.
كنت بس بسأل حد متلخبط, anyone confused, anyone wants to ask a question about use cases and scenarios?
No, it's very simple.
Okay. I just wanted to show you an example of that. Yeah, I think we'll see one. I'll just change the share for a second. That looks like that. Yeah. So this is a way of do you see this table? Yeah. So this is a tabular description of a transfer data use case for the mental health care system. Yeah. So you state who are the actors who are going to be using this use case, and there's the textual description, yeah, and what data is going to be exchanged, maybe as input or output. You can actually describe them or split them into input and output, and then there's the stimulus, i.e., how the particular use case is being triggered, and then the response of the system, yeah, what would the system do as a result of the stimulus and being provided with the correct data, and maybe other comments describing things like preconditions or post conditions. You can do that as well. So here the comment is the receptionist must have appropriate security permission to access the patient's information and the PRS, which is the patient record system. Yeah. So this is just one way of recording it. There are many ways of doing that, by the way. But this tabular description sort of describes in a structured way the use case for a particular actor. So it would have a name. This is by the way, this is the name of the use case. The use case called transfer data. So we'll find it on here. You see. So this would be the use case belonging to one particular type of actor for this system, which we call the medical practitioner or the medical receptionist. I'm sorry, in this case. Yeah. Right. So let's go back to the original presentation. Okay. Okay. So I'm just making sure that I'm looking at the same presentation as you do. Right. Yeah. Here's another way of documenting a function this time, not a user story, but a function that tells you what is the name of the function and a description of that function. Yeah, so there's textual description, there's narrative describing what this function should be like and what are the inputs of this function. Yeah, so they're like some readings of the patient's blood sugar or glucose level and the previous two readings, and on the basis of that, the system would calculate a dose. Yeah, and this is the source of this actual data, and the output is that the system would be computing an insulin dose to be delivered to the patient. And again, here some actions, exactly what's going to happen. Maybe you can put an algorithm here, a way of calculating the dose. What are the requirements? So you have to have two previous readings because you need to calculate the rate. Is this patient's glucose level going up or down, and at what rate? Yeah. So it's not just like an absolute value. You need a relative value as well to sort of say, is it going up or down? Is it a positive or negative gradient? And here precondition is a precondition about what is needed before the pump is actually activated. Obviously, the insulin reservoir needs to contain at least the maximum allowed single dose of this medication. And then there's a post condition because you put the new rate one of the new rates instead of one of the two readings. Yeah, so just shifting. So it's like a rolling average or rolling readings of the patient's insulin blood sugar level. Do you see what I mean? So again, we're using some structured tools of describing either the functions, if you're using a straightforward functional description, or a user story-like representation, describing what is the user doing to achieve a certain, complete a certain task, and this task is contributing to a certain goal. By the way, there's an entire sort of approach to, I'm going to put right here at the bottom, there's an entire approach to requirements engineering called goal-based requirements engineering. Yeah, whereby your fundamental elicitation or analysis technique is to describe user goals and decompose these goals into sub goals, and then you know, when you take that forward to design, you design how each of these sub goals are going to be satisfied, and what are the inputs that are needed, and what are the outputs provided after the task or the sub goal has been achieved. Lots and lots of methods and techniques, but at least you need to get to get the idea that we need a few formal, or like excuse me, not formal as in mathematical, but formal as in well organized and well described and systematic ways of describing your functions or user stories. Okay. Also, we can describe requirements using something called decision tables, or using a tabular representation, which is used to supplement natural language. I have to point out here, you should not exclusively rely on natural language to specify your requirements. Yeah? It's not a very good idea. Why do you think that? Why do you think that is the case? I'm saying, okay, my question is, you should not exclusively rely on natural language to describe or to specify your requirements. Can you think of why you should not be using only natural language? You can use it, but not on its own. Hello?
By natural language, do you mean like technical terms?
Yes. No, just text, just English or Arabic or whatever. Just natural language, narrative, just textual narrative.
It would be like some of the concepts itself would be hard to explain if it's just natural language.
Yeah. Okay.
So it would be, yeah, it would be sort of harder to grasp from the stakeholders' side. Like explaining it would be hard to the stakeholder.
Explaining it to the stakeholder, I think not actually. I think the opposite. Natural language would be easier to explain to stakeholders because you're not using any of your own sort of technical language or technical formalisms. So from the stakeholder side, yeah, maybe it's easy for them to understand, unless of course they don't use natural language anyway to specify an algorithm, for example, or how they do things. Maybe they use formulas or a programming language or a technically oriented language to specify what they do. But usually we actually use natural language to explain things more easily or more readily to the stakeholders and users. But what are the problems with that? What are the potential problems with that?
Problems with what, doctor?
Natural language, using natural language.
عشان misunderstanding.
بالضبط. And natural language is prone, yeah, or يعني subject to wide interpretations, and it can be easily misunderstood, or can be easily understood in different ways by different people. Yeah, and there are many. Actually, I'd like you to look up at examples of that in this chapter. There are examples of how natural language can be difficult to interpret or be interpreted differently by different people. I think I went through an example of that the lecture before last, so like last Wednesday. Yeah, how it leaves a lot of scope for ambiguity, tamam, and misinterpretation. So I'm not saying don't use it. It's just I'm saying do not exclusively rely on it. Your specs should not be only made of natural language. So we try to put some constraints in natural language to make it more structured and reduce the scope for ambiguity, and try to make sure that the specs would be understood in the same way by all stakeholders involved. This is really, really important. It's one of the biggest problems or pitfalls of requirements engineering, that people understand the requirements in different ways. So misunderstanding get unnoticed, yeah? Just they are sneaked into the actual description of the system and the design and the later programming. Remember when we said that errors committed in the requirements are much harder to fix because they're much more costly? Yeah, so if you don't trap them, if you don't catch them now, it will be very, very hard to catch them later. You just discover them right at the end where it's very costly to modify or change the system. Okay, right. So let's, yeah, so for example, the insulin pump system that pumps insulin into the diabetic patients bases its computations on the rate of change of blood sugar level, and a tabular specification would explain how to calculate the insulin in each case or for each different scenario. So let's look at an example of how that works. Now, this obviously would be needed, this representation, when you have something like a structured set of decisions, like it's anything else, really. Yeah, if the sugar level is falling, so the second reading is lower than the earlier reading, so the level is falling, then you give 0 dose. Yeah, if it's stable, if the second reading is the same as the earlier reading, then again you don't do anything. If the sugar level is increasing but the rate of increase is decreasing, yeah, so actually it has gone up, but the difference between the first and the second reading is less than the difference between the first reading and the reading before that, then again you give 0 dose. Obviously this is a medical decision, by the way. You need to be told this by a doctor, so, or a specialist who tells you, yeah, if we find that the sugar level rate of increase is decreasing, yeah, then we don't give anything, because it's just going on a lower, on a negative gradient, even though it has actually gone up. And the negative gradient is for the rate of increase. But if the sugar level increasing and the rate of increasing is stable or increasing, then we calculate a dose in this way. Yeah. So what is this? This is also called a decision table. So it's a way to structure your if then else statements, if you like, or to structure your conditions. You see here on the left, yeah, this column is a set of conditions. Now this is not programming language. Yeah, it looks like a programming language, but it isn't. It's just structured or tightly written English that explains the various conditions and what action should be taken on the basis of these conditions. Obviously, you need to specify the conditions fairly precisely. So for example, if you forget the equal sign, then there's a problem here. If you say if the rates are negative or positive, and you forget what happens if the rates stay the same, obviously this would be an error in the specification, because you have not said, you have not described what is the appropriate action if the rates are stable or are not changing. You see what I mean? Now, the nice thing about this formalism is that someone can actually sit down and review it with you. Maybe a doctor or a domain specialist, صح؟ زي ما عملنا في موضوع القطر محتاج تحسب مثلا deceleration rate or rate of stopping it that depends on the gradient it's traveling, as well as some other control variable. So a domain expert or an engineer or whatever can sit with you and read this and say, كلام ده مظبوط صح. Well, you don't know you forgot something. Yeah. So again, it provides you with a nice nice documentation of presenting to the domain expert to give you reviews and to make sure that things are going okay. Yeah. So again, we're still with ways of describing or specifying your requirements. So we looked at where is the thing? We looked at the diagram, yeah, pictorial representation or an image-based representation of requirements supplemented with text that describes each of these ones. And the text could be in this form, in the form of of these yellow forms that I presented to you earlier. Would you prepare for interviewing stakeholders in your project? So we need to ask the question, why do you need this system? What are the problems it's trying to solve? What are the inefficiencies in your organization? What are the things that are bugging you? What are the pain points? Who are the users? Yeah, what are the characteristics? Who are the stakeholders? And remember, the stakeholders is a superset of users. It's a wider scope. It has a wider scope than users because it just could be people who are not using the system directly but are interested in it. Okay, so we discussed ways of interviewing. Yeah, this was the description of scenarios. Yeah. So some guidelines for interviewing and documenting the result of your requirements investigation. Now here's ethnography that I think Kareem asked about earlier. So ethnography actually comes from social science. Yeah. And this is a nice example of interdisciplinarity that actually, as a software engineer, you still need to know about other disciplines and their techniques because they might be useful in a particular domain of work. Yeah, ما تبقاش يعني blindfolded كده into a particular discipline وخلاص مش عايز تعرف حاجة عنه, because often we find useful techniques from other disciplines. So social scientists develop this technique of living with the culture or the community they're trying to understand. تمام? So social scientists need to spend a considerable amount of time observing and analyzing how people work or how people interact with each other in a given culture or domain. They just observe, yeah, and as a result, of course, you can supplement it with some interviewing, but normally the people in the domain do not have to explain to you how they do the work. You just keep observing. You look at the social and organizational factors that are relevant to your system. Now, ethnographic studies of systems or domains of work have shown that work is actually more than just a formal description or a formal system model. There's a lot of richness in there, yeah? Things that are not easily observed or not easily articulated. Okay, so there's some stuff here about ethnography. Here's a definition. It's the study and systematic recording of human cultures. Yeah. It's mostly associated with or comes in the form of qualitative data, like they're not numbers, they're observations. Yeah. There's a set of techniques that help you achieve or do ethnography, like participant observation. Yeah, like interviews. Normally would involve a large amount of free form or non-structured interviews, yeah? Or I should say mostly non-structured. Yeah. So this is also important. Ethnographers immerse themselves in the culture that they study. Yeah, they just, they spend a lot of time in it. Maybe participate, do some work with them. Yeah, help them out, carry out some tasks. Tamam? And obviously there can be different levels of involvement, from like a fly on the wall thing, just observing and not interfering, not interacting at all, to actually joining the team and becoming a member of the team and doing things with them. Yeah, but if you're an ethnographer, if you're like a proper ethnographer and you want to do proper ethnography, you'd probably want to have a very high degree of immersion, but you don't have to do that all the time in software. Actually, let me, I have got some slides here just to give you an impression of what ethnography is like. You're observing a culture, observing what people do. So if you observe in domestic life, how people rest, how they work, how they interact with each other, how they cook, how they sit, yeah, etc., etc. And this diagram I think is interesting because this is an actual case study that used ethnography to elicit the requirements of the domain of air traffic control. Now, the people who use ethnography in this particular system found out some interesting things that would not have been obvious if they didn't use ethnography, which is that people's awareness of each other, what each other is doing, is very, very important. Now, the actual air traffic controllers were not aware of this, that they could not tell you, oh, I need to know what my colleague is doing next door or next to me. Yeah, they would not tell you that. It's just not in their conscious awareness that they need you that. But the ethnographers, when they observed, found that this is actually a critical element of them working together, that they have to be mutually aware of what each one is doing. Yeah, the sounds even that they make are very, very important. And that would not have been found out if observation of the ethnographic type have not been used. Another great success story, obviously, is the iPod, iPhone, blah 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 family of products by Apple. Now, the iPod, I understand, came to Steve Jobs when he was out of Apple for many years, and he was observing how people listen to music in the public domain. And he noticed that actually people do need to listen to music and manipulate music, as in stop and start or stop and play, select a track, jump forward and backward, while they're traveling, for example, with only one hand occupied, and the other hand being manipulating, being free to manipulate the device on which the music is recorded. Yeah. So these requirements came from observing and imagining, implementing new user experience. What can people do while they're traveling? Maybe they're using the bus or using a train or whatever. What are they doing, and how busy they are, and how they are busy, and how can I provide them with a device that is very easy to manipulate and navigate through a potentially very large number of songs and videos that are stored on a device of some description. And because this little device was able to provide a very distinctive and distinguished user experience, very highly refined user experience that is totally, to a very large extent, appropriate to the circumstances of the user, this product was a success. And I would argue that a fair amount of ethnography was used by Steve Jobs in finding out what people really wanted or what they needed, and their quest for listening to music while they travel, while they work, while they're jogging or playing sports. Yeah, so he kept observing. Steve Jobs said, I spent like 15 years observing what people do in the public domain, and that gave him ideas about what features a novel or an innovative music playing device was needed, were needed in such a device. I mean, what features would be useful. All right. Okay. Now, yeah, I'll just finish in 1 minute or so. Some of it also mentioned something called focused ethnography, which is really like a mix between using prototypes and prototype investigations and focusing the ethnography to answer the questions that have been thrown up by prototyping. Yeah. So you develop a prototype, let people use it, and through using the prototype, identify some issues or questions, and you try to answer these questions via ethnography. So ethnography is not like ethnography at large. You're not analyzing or observing all behavior, but you're focusing on the behaviors that can explain the issues that have been thrown by the prototype. For example, the prototype might not have an element of co-awareness in the case of air traffic control. Yeah, okay, so you do some ethnography to find out what kind of co-awareness, mutual awareness of each other's tasks that are needed. And they've actually discovered that they needed to know when one of them was occupied with following the path of a particular flight and when they finish. Yeah, so if they find they've struck when they used like a manual system, they would strike a chip, something like a chip or a bar, a piece of wood that has the flight detail on it on a hard surface. Yeah, they would strike like that. Yeah, can you hear this? Something like that. They would like, let me make a more realistic sound here. Look, something like that. So this sound that was generated inside the air traffic control was actually very important because it made one traffic controller aware that his or her colleague has actually finished dealing with a flight that they were serving or controlling, because the flight strip was struck on a hard surface, and this communicated some information that your colleague has just downed, or not downed as in downed, that helped one flight land safely. Yeah. So this is sort of diagram that tells you how focused ethnography, or how ethnography can be used in requirements analysis. Graphic analysis to give you lots of input about what people are doing and how they're doing it. You go through maybe a set of debriefing meetings to present what you found through ethnography. And this is really important because you get some feedback in the debriefing meetings. Yeah, you present your findings to the stakeholders, and maybe use some prototyping or some focused investigation to resolve some issues, and then you go back to the prototype evaluation stage.